Okay, lowest common multiple. Now, there are loads of ways of doing it, so I'm going to show the easiest way, and then I'm going to show the way that works with any number of any size. But because it's a calculator paper, when I'm trying to find multiples of 24 and 36, I can just use the calculator. So I'm going to do the multiples of 24 and the multiples of 36, and I'm going to stop when I find the same one in both lists that I made. Okay. Now, 24 times table, if you don't know how to do 24 times table, just add 24 every time. Okay. Now, I do know, so I'm just going to do it for a little bit. Okay, but again, if I want the next one, I can just keep going. Right, 36 times table, same principle, keep adding 36. Now, I'm going to stop already because I've got the same number in both. So the lowest common multiple is 72 straight away. Okay, that's the quick way of doing it. When I've not been asked to do prime factor, products of prime factors or anything like that, then this is fine. Okay, this is fine also if you are asked to do it and you can't manage to do prime factors, and you can rely on this method to back you up. However, I'm going to show you what prime factors is all about right now. Usually, they ask you to find the prime factors of one of these two numbers first. So, like 13a would be find the prime factor of 24. Now what we're going to do is break down both numbers. So it's an alternate method. You do not have to do this. You don't have to do the method. You can rely on this method. This is how I break down numbers into prime factors. I think of two numbers at times squared to make 24. Some students use repeat division. They have a line and they test values or test prime numbers starting with 2, and they keep breaking down a number. Now what I ask myself, are either of these numbers prime? Absolutely not. And then I draw two arrows underneath both of them and break them both down. That's 2 times 2. 2 is prime. That's 3 times 2. They're both prime. So I've found all the prime numbers or prime factors. 24. Do the same to 36. Any two numbers, so I'll just go 9 and 4. Both not prime, so I keep going. That's 3 times 3. Both of those are prime. This is 2 times 2. They're prime. That gives me the prime factors for 24 as 2 times 2 times 2 times 3. I just took the numbers in the circle, and this one is 2 times 2 times 3 times 3. Now some students like to represent this as 2 cubed times 3 and 2 squared times 3 squared, but I don't like to. I like to keep them as a chain, and then when I complete a Venn diagram, which is a method I've been using this year because I've seen it in other classes and I think it's a nice way of doing it sometimes. What you need to do is then put the values of the factors of 24 and 36 into this diagram. The middle section is where you've got numbers in both, so I've got a 2 and a 2 there. I'm just going to cross them out, put it there, 2 there and another 2 there, so it's going to go in the middle, 2 there, but not another 2 on that chain, so that's going to be by itself there, cross it off, a 3 there and there's a 3 there, so we've got that. 24 has been exhausted, and then there's a final 3 on the 36, which is by itself. The lowest common multiple is actually the highest common factor times the bits that are on the outside. Okay, so the middle section is actually the highest common factor. So if I times those two together, the highest common factor is 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. The bits are the numbers in the other parts of the Venn diagram. So I'm going to do 12 times 2 times 3. 12 times 2 is 24. 24 times 3 is 72. Okay. The reason this method is used is that no matter the size of the number, you can deal with smaller numbers to find the lowest common multiple. Okay. In a non-calculate paper, that is advisable when you've got large numbers that you're unsure of. Okay.